Modern corporations spend millions of dollars building an invisible fortress. They invest heavily in military-grade encryption, complex firewalls, and endpoint protection, security software installed directly on devices like laptops and phones to monitor for malicious activity. But that massive digital investment is completely bypassed if an attacker can simply walk through the physical front door of the building. You can have the most advanced cloud security in the world, and it won't matter if someone can sit down at a receptionist desk. To find these vulnerabilities before real criminals do, organizations hire experts for physical red teaming. These are highly authorized, simulated hacking engagements where professionals are paid to test the physical boundaries and access controls of a target company. Instead of attacking the servers, red teamers target the human firewall. They exploit basic social norms, like the polite urge to hold a heavy glass door open for someone carrying a tray of coffees, or the implicit trust we give to someone wearing a high-visibility maintenance vest. An enterprise-grade digital security system is functionally only as strong as its weakest physical access point. If the lobby is compromised, the network is compromised. This diagram shows exactly why so many buildings are vulnerable. Many corporate offices still rely on legacy access badges, operating on an unencrypted 125 kHz radio frequency, compared to modern smart cards that use a secure, encrypted 13.56 MHz signal. Because those legacy badges constantly broadcast their signal without encryption, an attacker can steal the data in a public space using a technique called brushing. They simply walk through a crowded coffee shop or subway car and bump their bag against a target's hip pocket or lanyard. Hidden inside that bag is a high-powered RFID antenna. In milliseconds, it captures the target badge's unique identifier, or UID, a static serial number programmed into the card to tell the building's scanners who is requesting access. With the UID captured, the attacker instantly writes that serial number onto a blank physical card. They now hold a perfect, functional duplicate of the employee's badge. By spoofing a legitimate physical identity, the attacker walks right through the turnstiles. The external digital firewalls designed to keep intruders out of the network are completely invalidated because the system believes the person walking inside is an authorized employee. Once inside the building, the clock starts ticking. The attacker's immediate objective is to establish persistent remote access before physical security guards realize someone is out of place. They look for active, unsecured LAN ports, local area network connections that link devices directly to the company's internal servers. These are routinely left open in empty conference rooms or tucked away behind reception desks. To bridge the physical-digital gap, the attacker deploys a rogue hardware implant directly into one of these active Ethernet ports. This network map illustrates the attack. The rogue hardware executes scripts to bypass the external firewall, initiating an outbound connection to the attacker's server. This creates a command and control, or C2, backdoor. The C2 tunnel allows the attacker to send instructions and extract data at will, establishing a permanent remote foothold. Hardware implants succeed entirely because internal networks are frequently configured to inherently trust any device plugged directly into their own walls. With a backdoor established, the attacker moves to escalate their network privileges. They scan the open office for their next target, an unlocked, unattended employee workstation. Here, they deploy a bad USB exploit. Operating systems are programmed to inherently trust human interface devices, or HIDs, the technical classification for standard equipment like keyboards and mice. The attacker inserts a malicious USB drive that appears identical to a standard thumb drive into the target computer. The microcontroller inside this specific USB doesn't register as storage. It instantly masquerades as a keyboard, injecting malicious PowerShell scripts, a task automation program built in Windows, at over 1,000 words per minute. Before the employee returns from the water cooler, the payload executes. In under 3 seconds, it steals local credentials or establishes remote code execution, granting the attacker the ability to run any commands they want on that specific machine. Traditional endpoint security software fails here. It cannot distinguish between a legitimate human typing on a keyboard and an automated malicious keystroke script firing at machine speed. So, how does an enterprise actually neutralize these specific physical-to-digital infiltration vectors? First, organizations must upgrade physical access controls to high-frequency encrypted smart cards. Upgrading the encryption standard mathematically eliminates the possibility of millisecond RFID cloning in public spaces. Next, they deploy Network Access Control, or NAC, as the primary defense against rogue hardware implants on the LAN. NAC is a security solution that strictly enforces identity policies on any device attempting to connect to a network. As this flowchart shows, a properly configured NAC instantly detects unauthorized MAC addresses, the unique hardware identifiers assigned to network controllers, or behavioral anomalies, immediately disabling the compromised port before a C2 tunnel can be built. This overarching defensive strategy is known as Zero Trust architecture. It is the strict mandate to never trust a device or user simply because they happen to be inside the building. Zero Trust eliminates the dangerous concept of a safe internal network, treating every single access request as potentially hostile. Architectural defenses must be paired with human vigilance. For endpoint attacks, this means enforcing a strict behavioral policy of locking unattended screens the moment an employee stands up. This simple keyboard shortcut completely neutralizes a bad USB attack. By locking the screen, the system requires secure authentication before any new input is accepted by the operating system, rendering the injected scripts useless. True enterprise cybersecurity is a continuous, integrated overlap of encrypted architecture, physical access control, and human awareness. You have to secure the code, but you also have to secure the door.